This is Pre-Calc 11, Chapter 1.1. We're going to be looking at arithmetic sequences. This sounds difficult, but it's nothing more than a linear function that has a domain of positive integers. Arithmetic sequences have a lot of applications because we tend to deal with whole units, like buying things such as donuts, candy bars, pencils, rulers, hamburgers, etc., etc. And for buying these things, we would never consider buying a fraction of one, because it would be silly to buy a quarter of a hamburger. Here's an example. It costs $30 for the first martial arts lesson. And the reason for this is because it includes your gi. And it costs $10 for every lesson afterwards. Write out the first 5 terms and find the formula. So the first lesson is $30. The next lesson will bring the total to $40, $50, $60, and $70. So our general formula, Tn, is equal to 10 times n, because it costs $10 for each lesson. And then we have 30 minus 10. And this can be simplified to 10n plus 20. Okay, remember n is our lesson number. So the first one, we have 10 times 1 plus 20 equals 30. So we always want to check to see that the first term is correct. And you might want to check a few terms after that. Okay, another way to construct your function is to use the point-slope form. Normally you see y here, but since we're dealing with term numbers, we have t. So we can just take t of n minus t of p is equal to m times x of n minus x of p. And p would be something like 1, 30. In this case, 1 is our first lesson, 30 is the cost for this first lesson. And we know the slope is 10 because it's $10 per lesson. So to do this, it's t of n minus 30, we get the 30 from here, equals 10 times xn minus 1, we get the 1 from there. And then we simply solve Tn. And we expand this, xn minus 10, and then we bring the 30 over, that's plus 30. Okay, so we have the same formula, and we can just simplify this to just putting the n in place. We have the same answer, so that's good. It means everything's working. So we can have a general formula. Tn is equal to t1 plus d times n minus 1, where n is a term number. And d is the common difference. And we write n is an element of n1. And this is as opposed to n0. And this symbol is element of. And this is natural numbers. Starting from 1. If we write n0, this is natural numbers from 0. And another way problems are posed, we'll be given a term number and its value, and another term number and its value. And we're supposed to find a general term again. Okay, to find the general term, we need another formula. Tn equals Tm plus d times n minus m. So that's another formula you can use. So we have T19 equals T4 plus d times 19 minus 4. Now we substitute the values in. We have 55 equals 100. plus d, and 19 minus 4 is 15. Bring the 100 over to the other side, that's negative 100. 55 minus 100 is minus 45. And we have 15d. So d equals negative 3. So we use the same formula again. We need to know the starting term, t1. So we can use either t4 or t19. Let's just choose t4. So t1 minus 3, because we know what d is now. And we have 4 minus 1. And substitute, 100 equals t1 minus 3 times 3. So t1 equals, this is 100, this is minus 9. When we bring it over to the other side, it becomes plus 9, so we have 109. So our general answer is Tn equals 109 minus 3 times n minus 1. And this is our final answer. So recognizing patterns is a big part of math. And we need to determine whether these are arithmetic sequences. So we're increasing by 3, increasing by 3, increasing by 3, increasing by 3, increasing by 3. So yes. And d equals 3. Down by 4, down by 4, down by 4, down by 4, down by 4. Yes. If you're given a bunch of terms, you have to check them all out. Even if the first few terms work, the next one might not. Here we have up by 2, up by 2, up by 2, but this is down by 6. So we have to say no. 8 to 2 equals negative 6. Up by 0, up by 1, up by 1, up by 2, so this is definitely a no. Here we have up by 1, up by 2, up by 4, so this is a no. And we can say d not constant. If you look at this, the pattern is actually multiplying by 2 at each step, but that's for later on. Okay, once we're given a general term, we can answer other questions. So here's a general term. What is t of 72? Or what is the 72nd term? Well, if we were to add, or in this case, subtract 2.5 every single time, you'd have to do a lot of subtracting before you get to your answer. But we can just plug 72 into this formula. So t of 72 equals 73 minus 2.5 times 72 minus 1. So this is 73 minus 2.5 times 71. And 73 minus 177.5, and we get negative 104.5. Next question, is minus 73 part of this sequence? Okay, so we don't know the term number, we just plug this in. Minus 73 minus 2.5 times n minus 1. Now we just solve for n. Bring this over the other side, so that's minus 73. So that's minus 146 minus 2.5n plus 2.5. We bring the 2.5 over to the other side, so that's negative 2.5. Now we have minus 148.5 minus 2.5n. Divide both sides by negative 2.5. N equals 59.4. So n is not an element of n1 because these are integers, the natural numbers. So no, not part of the sequence. And this is not. So not element of. Part C, is negative 62 part of this sequence? Again, we just plug in 62. We don't know what the term number is. We bring 73 over to the other side. That's negative 73. Now we need to bring the 2.5 over to the other side, so that's negative 2.5. And we divide both sides by negative 2.5. So n is an element of n1. So yes, it is part of the sequence. Finally, with D, is 78 part of this sequence? And we get 5, negative 2.5, n plus 2.5. Again, we bring this over to the other side. It's minus. 5 minus 2.5 is 2.5. Divide both sides by negative 1. We have n equals negative 1. This is an integer, but it's not part of the natural numbers. So no, it is not part of the sequence. Okay, so we have this general term. Again, we also have another general term. You can use Tm equals Tn plus D m minus n. I know I swapped the n and m from the previous one, but as long as the formula is consistent, that's fine. So n must be an element of n1, but nothing says that our difference needs to be in n1. So D can actually be any real number, and we write real number with 2 slashes there and then the R. Okay, so there's nothing that says that D has to be part of that. D just has to be a real number. And you want to notice that if D is greater than 0, our sequence is increasing. And if D is less than 0, our sequence is decreasing. And that completes this lesson.